So let's go ahead and start chapter 9, which is hypothesis testing with one sample. So if you go back to high school and remember in biology class, you guys often did hypotheses, which was an educated guess on what would have happened in an experiment. Basically, we kind of do that in statistics, but we have some differences. So in this chapter, you're going to learn to conduct hypothesis tests on single means and proportions. You will also learn about errors associated with these tests. Hypothesis testing consists of two contradictory hypotheses or statements, a decision based on the data, and a conclusion. So in order to perform a hypothesis test in this class, you're going to set up two hypotheses, collect sample data, but in your case, the data is already going to be given to you. You're going to determine the correct distribution to perform the hypothesis test. And there's three, and they're pretty easy to determine. So just know that there's three that we're going to learn about. And once you learn one of them, the other two become easier. You're going to analyze the sample data by performing the calculations, which you'll do in the calculator. And based on those calculations, you're going to reject or decline to reject the null. And then you're going to make a decision and write a meaningful conclusion. So let's talk about the hypotheses, the null and the alternative hypotheses. So the null hypothesis we denote as HO states that the parameter is equal to a specific value. The equality sign will always be in your null hypothesis. It will never be in the alternative. The alternative hypothesis, which is HA, states that the parameter differs from the value specified by the null hypothesis. So your alternative and your null are always going to be different. So there's three cases for your alternative hypothesis. It can be a left-tailed, which is a less than scenario, and the parameter is less than the given value in the null hypothesis. It can be right-tailed, where the parameter is greater than the value given in the null hypothesis, and it can be two-tailed, and the parameter is not equal to the value given in the null hypothesis. So I made a table, so it might be easier to look at. Again, that left-tailed, that right-tailed, and then the equals to. So if you look over here in the left-tailed, you see in my alternative, I have my mean is less than the population mean, which makes my null, the mean is greater than or equal to the population mean. So again, I have that equality sign in the null hypothesis, even though there's a greater than symbol with it. Right-tailed, it's the same thing. The mean is less than or equal to the population mean for the null, and the alternative, the mean is greater than the population mean. So the equal one over here gets a little bit tricky. So the null hypothesis is the mean is less than or equal to the population mean. The alternative is the mean doesn't equal the population mean. So unfortunately, in this book, it's a little confusing because when the mean equals the population mean, the alternative can be not equal, greater than, or less than. So you want to watch out for those things. So let's do some examples. The mean number of years Americans work before retiring is 34. The null and the alternative hypotheses are, the null is the mean equals 34, and the alternative is the mean doesn't equal 34. Where did I get that from? Well, the question says the mean number of years American worked before retiring is 34. So it's saying the mean is 34. So I can't put that in my alternative, so I have to put it in my null. And then when I want to put the mathematical opposite in my alternative, I just put that the mean doesn't equal 34. The next example is the mean number of cars a person owns in their lifetime is not more than 10. So what does that mean? It means the number of cars you own in your lifetime will never be greater than 10. It can be equal to 10, but it will never be greater than. So because it's saying that it's going to be less than or equal to, I need to put that in my null. So as you can see here, the mean is less than or equal to 10. So that makes the mathematical opposite of that for the alternative, the mean is greater than 10. So let's look at the next one. Europeans have a mean paid vacation each week of 6 weeks. Yes. So what it's saying is the mean vacation time equals 6 weeks. So again, in the null, I have to have the equality. So the mean equals 6 in the null. The alternative is just the mathematical opposite. The mean does not equal 6. Here's another example. Private universities' mean tuition cost is more than $20,000 per year. All right, so it's saying that tuition costs more than $20,000 per year. It has nothing to do with the equality sign. So in my alternative, I'm going to put the mean is greater than $20,000. So what would that make my null? Well, that would make my null that the mean is less than or equal to $20,000. So I know these are kind of confusing, but if you play with them, you'll start to see how they go and get the rhythm for them. So now let's talk about proportions. Proportions work the exact same way as the means. The only difference is you're using percentages, and instead of the mu for mean, you use a p. Again, here are the scenarios, just like we used with mean, and you can use this as a guide. Left-tailed, p is less than the number for the alternative. Right-tailed, p is greater than the number. And again, for where p equals the number and the null, you can have all three scenarios. All right, let's do some examples. At most, 60% of Americans vote in the presidential election. Okay, it didn't say anything about a mean, so I know this is a proportion because it has a percentage. So it's saying at most. So what does that mean? That means at most means 60 and below. So because it's equal to 60, I have to put this in the null hypotheses. So I'm going to do p is less than or equal to, and I converted that percentage to a decimal. So it's p is less than or equal to 0.60. So then all I do in my alternative is put the opposite. So p is greater than 0.60. The next example is 29% of seniors drink alcohol during the weekend. So it's not saying less than or greater than, it's just saying 29% drink alcohol. So for my null is p equals 0.29. My alternative is p doesn't equal 0.29 because I didn't care if it was less than or greater than. I just want to know if there's a difference. The next example. About half of Americans prefer to live away from the cities given the choice. Again, in my null, p equals 0.50. My alternative, p doesn't equal 0.50. And the last example. The chances of developing breast cancer is under 11% for women. Okay, I don't have anything about equality in there, do I? It doesn't say under and equal to 11%. It doesn't. It just says under. So I'm going to go and quickly fill out my alternative, which is p is less than 0.11. My null then becomes the opposite of that, which is p is greater than equal to 0.11. So you're really looking for those equality signs to help you choose which scenario you need to pick.